What happens when you're moving in two dimensions instead of one? When you move on a circular path, you're moving not only on the x and not only on the y, but along both at the same time. So when you move in a circle, you've got this velocity along the tangent, but you've also got this velocity that pulls you back towards the center. There's two things going on at the same time. So when you talk about uniform circular motion, where we move at constant speed along the circumference. Okay? This direction is always tangent to the circle. We can't call it x direction, and we can't call it y direction. We have to call it tangential. Because it's a circle, that direction is always changing. So the two axes that we're going to use, the references that we're going to use, are radial and tangential, or tangent. Tangent to the circle is always touching the point and then extending at right angles to the radius. The radial is along the radius. That's pretty simple. So as you move around the circle, these references are going to change because you might be down here where radial is up this way and tangent is perpendicular to that. Or you could be at this part of the circle where radial is to the right and tangent points straight up. Or you could be at the top of the circle where radial is down and tangent is to the right. So the reference will switch, but they refer to the same thing. These are separate axes. You can't combine them. And so the calculations are separate also. So first, let's talk about just tangent, right, to the circle. On the tangential axis, when we're talking about the motion, right, this is still our kinematics equation, right? But because it's uniform circular motion, acceleration along the tangent is 0. So it's not accelerating this way along that path. So we take a tangential, that's what the capital T means. Tangential acceleration is 0. The time we're referring to is the time to make one complete circle. One complete circle is called a period. The time is called the period. So we sometimes abbreviate that with a capital T or a T with a subscript little p. So the time it takes to travel in one complete revolution is the period. The distance that you've traveled along one complete revolution is called the circumference, which you should know is 2 pi r. The most important part is putting that together and talking about tangential velocity. We know it's constant speed, so acceleration is 0. The period is this time here, and the circumference is the distance. So to calculate this tangential velocity, we do dt divided by the period. Circumference divided by period will give you this velocity. This only works if you're moving at constant speed or you're calculating the average speed around the outside of the circular path. In the next video, we'll look at the radial axis and what's happening there.